verifying 1 minus cosine of x over sine of x equals sine of x over 1 plus cosine of x. To verify this identity is to start with one side and arrives at the other. Usually we start with a more complicated side. In this case, either side is equally complicated, so we start with the left-hand side. The left-hand side is 1 minus cosine of x over sine of x. The first thing we are recommended to do is to rewrite these trigonometric expression in terms of sine and cosine, but they are already in terms of sine and cosine. The next thing is to multiply a well-chosen one. A well-chosen one usually in the form of the conjugate. When we talk about the conjugate, it has to be a binomial, an expression that has two terms. In this case, it is the conjugate of the numerator, which is 1 plus cosine of x, but it had to be a well-chosen one. If we multiply 1 plus cosine of x in the numerator, we must multiply 1 plus cosine of x in the denominator as well. We then multiply the two fractions. The numerator is the product of the two conjugates, so it is the difference of two squares. 1 squared minus cosine of x squared. The denominator is sine of x times 1 plus cosine of x. And in the numerator, it is 1 minus cosine squared of x over sine of x times 1 plus cosine of x in the denominator. Now, the next step is probably the more challenging part in establishing an identity, and that is we need to be able to recognize the variations of any prior identity that we know. For example, the trigonometric identity that we know, the basic Pythagorean identity, is cosine squared of x plus sine squared of x equals 1. So we need to be able to recognize that sine squared of x equals 1 minus cosine squared of x somehow. And if we can recognize that, the numerator is now only sine squared of x, and the denominator is sine of x times 1 plus cosine of x. In the numerator, there are two factors of sine of x, so we can cancel one of the factor in the denominator and end up with one factor of sine of x in the numerator and 1 plus cosine of x in the denominator. And this is the right-hand side. We start with the left-hand side, perform the algebraic manipulations along with any prior known identities, and then we arrived at the right-hand side. By doing so, we establish the given identity.